In this part, same thing as before, solve it like a linear equation. You want to get the variable by itself. So, first step, I'm going to cancel out my minus 8. So, I'm going to add 8 on the left side, add 8 on the right side. So, I will have 10x squared on the left, and on the right, negative 38 plus 8 will be negative 30. From there, to get x squared by itself, I'm going to divide both sides by 10. So I'm going to have x squared equal negative 30 divided by 10 will be negative 3. After that, when you're trying to get x and it's x squared at the moment, you're going to have to do the square root so that you can get rid of the exponent. So I'm going to square root the right side also. So at the moment it's going to be x equal plus and minus the square root of negative 3. Now here, we cannot just end it like what we have right now, because according to what was covered in the previous section, 15.7, whenever we have a negative number inside the square root, that means we're going to be working with imaginary and complex numbers. So the first goal is to make negative 3 become positive. So what I'm going to do is I'm going to break down negative 3 into two numbers, where one of the number is going to be negative 1. So plus and minus the square root of negative 1 times the square root of 3. So we know that negative 1 times 3 will equal to negative 3, which is great, because now, as you have these two factors, we now have a positive square root of 3, and here you can rewrite the square root of negative 1 into an imaginary number. So that means it's going to be equal plus and minus. The equivalent form of square root of negative 1 is I. And I'm just going to bring down square root of 3 and put it next to the I, like so. So x equals positive negative I square root of 3, and that will be your final answer. So if you end up with a negative number inside the square root, as long as you did the work correctly, then you need to simplify, and you're going to end up with an I, indicating that you have imaginary numbers or complex numbers. So make sure that if you have a negative number inside the square root, make sure that your work is correct. If so, then you must follow the steps as shown here, where you should have an I in your final answer and not a negative number inside the square root. In this example, we have 10n squared plus 9 equals negative 40. So, just like before, solve it like a linear equation. What I'm going to do here, my first step is I'm going to cancel out this 9. Therefore, I'm going to subtract 9 on both sides. So I'm going to have 10n squared on the left side because my 9's cancel out. And on the right side, negative 40 minus 9 will be negative 49. Afterwards, I'm going to divide both sides by 10 so that I can get the n squared by itself. So it's going to be n squared equal negative 49 over 10. From there, if you want to get n squared to become n, meaning that you want to get rid of the square, you're going to have to square root both sides. And just like in the last example, you're going to have a negative number. So here, I'm going to do two steps at once. We're going to have n equal plus and minus. My first step is I'm going to pull out the negative. So we're going to have negative 1 here. So the square root of negative 1 times, we're going to have the square root of 49 in the numerator over the square root of 10 in the denominator. So let me repeat. Since you're doing a square root of a fraction, you can rewrite it as a square root of the numerator over the square root of the denominator. So let's continue with this work, and I'm going to rewrite the work over here for more space because this one right here involves a lot of steps at this point. So again, we have n equal plus and minus the square root of -1 times the square root of 49 over the square root of 10. So let's simplify the parts that we can at the moment. You can rewrite the square root of -1 into I. So we're going to have n equal plus and minus I times, now for the fraction in the numerator, square root of 49, it's a perfect square number, so the square root of 49 is 7 over, now for the square root of 10, it's not a perfect square number, so that means we're going to have square root of 10 in the denominator. Now in 15.5, when we're dividing with radicals, we cannot have a radical in the denominator of a fraction. So what we're going to do is we're going to rationalize the denominator, meaning you're going to multiply the numerator and denominator by the radical you have in the denominator. So that means I'm going to multiply top and bottom by square root of 10. So we're still going to have n equal plus and minus I times, now here we have a fraction times a fraction, so numerator times numerator, so 7 square root of 10 over the square root of 10 times the square root of 10 will be square root of 100. So you can still simplify that, so it's going to be n equals plus and minus I times 7 square root of 10 over the square root of 100 is a perfect square number, so the square root of 100 is 10. So next I'm going to finalize my answer, n equal plus and minus, I'm going to have the I multiplied to the numerator, so it's going to be 7 I square root of 10 over 10. And that's going to be our final answer. And let me box that up. So for this example, we were working with negative numbers, so therefore that's why we have I in our final answer. But at the same time, we had a radical in the denominator. So whenever you have a radical in the denominator, you have to rationalize just like how I did over here. I multiplied the numerator and denominator by the radical that we have in the denominator. So if I have square root of 10, I'm going to multiply top and bottom by square root of 10, because when you multiply in the denominator, you're going to get a square root of a perfect number, perfect square number, and from there you should be able to do the square root of that perfect square number. For example, like this one right here, the square root of 100, which will equal to 10. And now here you can clearly see that you don't have a square root anymore. So again, if you have a square root in the denominator, make sure to rationalize it, so that way at the very end you do not have a square root in the denominator.